be multiplied with your 100 pounds. So it will become your polish load will be 256 into 100. And you have a maximum stroke length. This 144 will be your maximum possible stroke length for your specific pumping unit. So this is not only the stroke length you can use, this will be the maximum. You can use a lower stroke length. You have this structural data. You can have your pumping unit size can be around 1824, can be 912. But in ONGC, the highest I have seen is your 640. And in Agartala, especially in Tripura, I said, our highest is 456, 456. And for knowing when you go to the field and you see a sucker rod pump, how will you know your pumping unit size? You will be able to know using a board where your pumping unit size will be given. And in this board, you can see your pumping unit structure. It will be either it's a crank balance or beam balance or your air balance. So you will be able to identify. And as well as other than this, you have your setback distance. This is basically the distance between your well center to your unit base. This is your unit base. So this distance to this distance is your setback distance, which is very important when you are installing your surface unit. The first thing you need to consider is your setback distance. Moving on, and now we'll see the sucker rod string. In your subsurface part, you have your sucker rod. This is your sucker rod. And you have your coupling. This will be your coupling. You can connect using this coupling. You can connect the same size of your sucker rod. If your sucker rod is 7x8, using this coupling, you can connect only 7x8. And you have crossover coupling. This will allow you to connect a different size of sucker rod. The sucker rod size can be 7x8, 3x4, or 6x8, or 5x8. So this crossover coupling allows you to connect different size of your sucker rod. And you have your pony rod. Pony rod is basically a short length of sucker rod. This sucker rod will come according to the API with 3 different lengths. You have your 25 feet, 30 feet, and 35 feet. Generally, you are going to see 25 feet of sucker rod. Pony rod is a small length of sucker rod, the same size, with your sucker rod. This is your pony rod. This will be your pony rod. The pony rod can be of 2 feet or 4 feet or 6 feet or 8 feet. And you have your sinker bar. You have your sinker bar. Sinker bar is a larger diameter of your sucker rod. This is your sinker bar. The length will be same with your sucker rod, but it will have higher weight as well as higher OD. And in sucker rod, we are classifying the size with 1x8 increment, 1x8 inch of increment. So if you have 8 inch, 88, it will be your 1 inch. If you have 77, that will be of your 7x8 inch. 6 will be your 6x8 or 3x4 inch. And similarly, it will go a bit like that, 5x8, 4x8, or half inch. In sucker rod, you have 3 grades. You have the grade K, and C, and D. The common grade you will be using for unloading water will be your grade D. which is made of carbon or alloy. It has a tensile strength of this much, and the maximum will be 1.4 lakh psi. Why you need sinker bar? Let's see. You need sinker bar because mainly when you are installing your sucker rod, you are going to install it like a tapered string. You call it the taper string. You are not going to install only one sucker rod size. You are going to install 3 or 2 combination of your sucker rod. It could be your 1 inch combined with your 7x8 inch or your 3x4 or 6x8 inch. So when you combine your sucker rod, the highest size will be at the top, followed by the second largest or the third largest. Usually in shallow depth, you may only use one single size sucker rod, either it's 1 inch or 7x8. When you combine 3 sucker rod string or 2 sucker rod, you are going to see the smallest size at the bottom. Now your sinker bar will play a role, because when you use the smallest size at the bottom during your downstroke, when your pump reach your pump depth at the bottom, you are going to see a buckling. Your rod will buckle and it may compress because of your load above your sucker rod, above your pump, because there will be a higher load of 1 inch and 7/8 that will act on your 3x4 inch sucker rod. So it will buckle. It may destroy, give damage to your tubing as well as your sucker rod. So you are going to use a sinker bar. Your sinker bar will be higher than your other 2 sucker rod, or maybe you use the highest sucker rod. If you use your sucker rod combination 1 inch, 7x8 or 3x4, you may use your sinker bar size as 1 inch. If you have a combination of 7x8 and 3x4, you will use your sinker bar to be 7x8. Now let's see the sucker rod string design. In sucker rod string design, you're going to follow your API 11 report, API RP11L. I will request everyone to note down this API number, API RP11L. From this API report, you will be understanding your string design more thoroughly. All your sucker rod string design will follow your API 11. The first thing you need to know is how much liquid you want to unload from your well. And then you select your pump size. After selecting your pump size, you are going to select a rod combination. So let's see here an example. API 76D combination means that your sucker rod is either 7x8 inch or a 6x8 inch sucker rod, and which will be of your class D sucker rod. Now let's say our pump is selected 1.5 inch pump size, I mean the plunger diameter. Let's have a look at here. Now you have your 76 sucker rod combination, which is your 7x8 and 6x8. You have your pump size, 1.5 inch diameter. Here, when you use your 76 combination sucker rod and 1.5 inch, depending on your size, you are going to see a tapered percentage combination. What does it mean? So if you look at here at the top, you are going to see a combination here, 76, 3x4. 3x4 means 6x8. So when you select your combination 76 with a 1.5 inch plunger, your rod combination will be 33.8% of 7x8 and a 66.2% of 3x4. Now let's give an example. Your pump depth is of 6,000 feet. Like I said, your sucker rod length will be of 25 feet. So Your 6,000 feet will require 240 number of sucker rod. You know the number of sucker rod you are going to use, but you don't know the combination. And you select based on your well parameter, how much tensile strength you would require for uh, unloading your water. After considering those things, you select, suppose, 76 class D. Here you see that the 76 class D will be 7 by 8 will be of 33.8. So 33.8 you multiply with your depth. So you are going to use 81 number of 7 by 8, and you are going to use the remaining number would be your 6 by 8 or 3 by 4. That would be 159. So if you multiply this with your sucker rod length 25, you are going to see it will be equal to this. So that's how you are selecting your sucker rod string, how much you have to use your 7 by 8, as well as how much should be your 6 by 8. Now let's see the subsurface pump. Subsurface pump will be your, will have your component of barrel, plunger, standing valve, and traveling valve. There are two types of subsurface pump. One is your insert pump, or you say rod pump, and the other will be your tubing pump. In your tubing pump, your barrel, plunger, your pump barrel is connected with your tubing. So you will have a higher displacement volume in your tubing, and in insert pump, your barrel will have a different part, and this will be your tubing. So in insert pump, you are not, your pump is not an integral part of your tubing. So let's see the disadvantage and advantage of insert pump and the tubing pump. The advantage of the tubing pump is you have a greater displacement than the insert pump, because you have your larger plunger diameter as well as your barrel, because your pump barrel is a part of your tubing, and you will be able to uh, perform a maximum production from your tubing pump compared to your insert pump. The disadvantage would be when your pump is failed, or your standing valve or your traveling valve is leak. You are, if you want to service your pump, your barrel, or your valves, you are going to pull out all your tubing string. So you are going to waste your time and your money commissioning your rig. And in insert pump, as I said, your pump barrel is not a part of your tubing. You can remove your barrel, your plunger, using only your sucker rod. You may not require your tubing to be pulled out. The disadvantage would be it has a smaller pump diameter, and it has a smaller capacity for displacing your liquid. Let's see the pump classification. You are classifying your subsurface pump into two, mainly your rod or your tubing. But in rod, depending on the made, the construction, you have different types. RHA would mean your rod and have a stationary wall barrel and top anchor. Let's see. We classify according to the API. This will be API 11B. Now let's have an example here. This is your pump designation. So what this 25 means? This 25 would indicate your tubing. If it's 15, your tubing size will be of 1.5 inch. If your tubing is 2 inch, it will be of 20. And 25 means your tubing is of 2.5 inch. Basically, your OD will be 27 by 8, which is the common tubing we use in ONGC. And this 175 would indicate your plunger diameter. This is very easy to understand, because 175, you just put a point here. So that means you have 1.75 inches plunger. If it's 150, that will be 1.5, and so on. Like this, you will designate your pump. And R will means your rod pump or your insert pump, and H will means your heavy valve. Your type of your barrel can be of this type. Your barrel can be heavy valve pump or thin valve with soft pack, or heavy valve with soft pack. And A is your seating assembly. If it's of top anchor, you denote it as A. If it's bottom, you denote it as B. If it's a traveling barrel pump, you will denote as D. And the next is this 16. 16 is your barrel length, the length of your barrel. And inside your barrel, there will be a plunger. So this 4 will indicate your plunger length. It is of 4 feet. And the last part is your extension. Now let's understand clearly. This is your pump, your subsurface pump. This is your subsurface pump. And the green part is your barrel. So this 16 would indicate the green part, the length of the barrel, 16 feet. Inside the barrel, you have a plunger. The plunger is inserted using your guide rod. There is a small rod here inside. You can see here, this is a guide rod. So inside the barrel, you insert your barrel plunger, which is of 4 feet, for example. And these 3, the last denotation, the 3, this would mean your extension. This is your extension part. You will have 2 extension, which is at the top and at the bottom. This is your top extension part. This 3 would mean it's either a 2 feet extension at the top, or 1 feet extension at the bottom, or 1 feet extension at the top, or 2 feet extension at the bottom. Now let's go into the subsurface pump components. You have your barrel, you have your plunger, you have your standing valve and traveling valve. The whole component, the whole part, this will be your barrel. Inside this, you have your plunger, and there is one valve in your plunger that will be called your traveling valve, because it will go up or down as you have your downstroke or upstroke. And this will be your standing valve, which will be remaining at its same position. That's why it's called your standing valve. And these 2 valves will be of NRV. That means that the fluid will be able to go upwards, but it won't be able to go downwards. Like I said, this is your barrel. Okay, this is your bottom extension. Why you need this extension? Because you want your standing valve assembly to be located outside your barrel, because your barrel will have a smaller diameter than your tubing pump extension. This will be your bottom extension. Your standing valve will locate here. If you see from this from the bottom, your standing valve will locate. Your standing valve will be of ball or seat type. It will look like this. Excuse me. You have a ball and a seat. This will be a ring, ball and seat. So fluid will be able to move upwards, but when it tries to move downwards, your ball will seal a hole in your ring. So you will only see a one-way flow inside your tubing. Now let's see the working of your subsurface pump. When you, let's start from the downstroke. When your downstroke begins, your traveling valve will open, because the pressure inside your chamber, let's say this is your upper chamber, this is your lower chamber. Only when your upper chamber pressure is lower than your lower chamber pressure, this will be opening. So the lower chamber has enough pressure to lift your ball. So then only your fluid will be able to move inside. Basically, when your sucker rod move downwards, we call it the downstroke, then your traveling valve is open. And you have your upstroke. In your upstroke, your standing valve is open because your fluid will be moving through your tubing from the bottom. Then that fluid has enough pressure to open your standing valve, and then it will be open and your fluid will store here. And as you move upward, your fluid will, whatever is stored inside your plunger will be moving upwards. So basically that is how you are unloading your water. What you need to know is that during your downstroke, your traveling valve will open. When the traveling valve opens, your fluid inside your barrel will be moving into your plunger. And then during the upstroke, whatever the fluid is inside your plunger will be lifted upwards. And during that, your standing valve is open and your fluid will move into the chamber. So this is called the compression chamber. Now let's see how we are installing our subsurface pump. Basically, these are the steps of installing your subsurface pump. The first thing is you need to move your rig to the side. When you move your rig to the side, you will remove your Christmas tree and you will install your BOP. We call it nipple up and down. Nipple down means you are removing, nipple up means you are installing. So you nipple down your Christmas tree and you nipple up your BOP. After that, you are going to remove all your tubing because you want to install your subsurface pump at the bottom. So this is your subsurface pump. You have your sucker rod, your sinker bar, and this is your pony rod. So the first thing you are going to do is that you are going to run one or two tubings, which we call it the tailpipe, because during the upstroke and the downstroke, because of the movement, your tubing is going to buckle, similar to how your sucker rod buckles above your pump. So in order to avoid your buckle tubing, you will install one or two tubing. We call it one or two singles. One tubing means one single, and two tubing basically means one stem. So this will be your tailpipe in order to remove your tubing buckle to make your tubing steady during upstroke and downstroke. So after that, you will connect your subsurface pump with your tubing, and then you started lowering down into your wellbore. After every 10 to 15 singles or 10 stands, every 10 stands while you are running your tubing, you are going to test your tubing. Testing means you are going to forward pumping water into your pump. That you have to test it, pressure test it at 100 kg per centimeter square. If it holds the pressure, if there is no decline or if there's no decrease in pressure while you are testing, first you need to check the pressure is holding or not. If the pressure is not holding in your pressure gauge, if it started to decrease, you are going to check, is there any return in your annulus or your pit, your mud pit? Because if you see a return in your pit, it means that your standing valve is not working. Basically, some fluid is passing through your standing valve. So you are going to check any return in your annulus. If the pressure, the 100 kg holds by the pump, you will continue your tubing running in. So every 10 stands or every 10 singles, basically every 10 stands, you are going to test your pump at 100 kg. So remember that when you are working in a walkover rig, whether it's private or government, when you are installing your pump, subsurface pump, you need to test your tubing or the pump at every 10 stands at 100 kg. Now, after lowering your uh, subsurface pump, then you will be started installing your sucker rod. So the sucker rod will, the first thing that will be run below the sucker rod will be your plunger. You are going to run your plunger separately if it's a tubing pump. But if it's an insert pump, you are going to run only tubing. At that time, you are not going to be able to test your tubing. So you may need your pump out plug to test your tubing integrity. Is there any leakage in the tubing? If there is a leakage in the tubing, you need to pull out the 10 stands that you have tested earlier. So you pull out the 10 stands and then you test it again. If there is any pressure loss, you remove another 10. And you tested it again. If the pressure holds, you add another 10. Likewise, you are going to either remove your tubing as well as adding it. Now you lower your plunger into your uh, tubing. Once it reach your all your sucker rod load will be on your traveling block at the rig. So you are monitoring the load. As you add more and more sucker rod, the load will increases. How will you know that the sucker rod reach the standing valve or the barrel? So there will be a sharp decrease in your load at the traveling block. So basically it may be zero load. So at that time you will be able to know that you are reaching your pump depth. After that, you are going to uh, adjust your polish rod by using your pony rod. This pony rod is used for adjusting your polish rod with your sucker rod, because your sucker rod is of 25 feet. If your depth is of, let's say, 2,000 meter, at that time you cannot only use your sucker rod, because some part will be remaining or some part will be a little bit shorter, like maybe 19 feet. At that time you are going to use pony rod that will be 8 plus 8 or 4 into 4, something like that. So you are going to adjust your polish rod using your pony rod. After you adjusted your polish rod, basically you need to adjust your polish rod 1 to 1.5 feet above your stuffing box, so that you will be able to hang your sucker rod to the surface unit. You have your stuffing box. This is your stuffing box. Your stuffing box, inside your stuffing box, it is packed with nitrile rubber. This is your rubber packing. When you tested your pump, after you are installing this stuffing box and adjusted polish rod, you are going to test your pump at 60 kg. So you will close your flow arm valve. You will close your flow arm valve, and then you're going to test this by lifting the polish rod using your traveling block. So basically you are mimicking the surface unit, lifting your polish rod up and down. So you are going to test your pump at 60 kg. If the 60 kg is held by your pump as well as your stuffing box, that means that your pump is working. And if you notice there is any liquid return through it, that means your pump is working. If it's not, you are going to circulate your pump, reverse circulation. You will do your reverse circulation. You will circulate water or your workover fluid from the annulus through the tubing. As I said, your standing valve and traveling valve, the fluids can go upwards but not downwards. So when you tested before installing the stuffing box and the polish rod, the sucker rod, you are tested using the forward testing. That is, you are injecting water using pump through your tubing. After you install your sucker rod as well as your polish rod and your stuffing box, you are going to test it using your polish rod. You are going to give a reciprocation motion in your rig, and if the pressure holds, your pump is okay. And if there is any leakage in your stuffing box, you are going to tighten your stuffing box. Suppose you have a leakage here. If you have a leakage here, you are going to tighten this nut and this nut. And if you have a leakage in this level, you will tighten this and this. Similarly, if you have a leakage here, you are going to tighten this, and there's leakage, there you are going to tighten these nuts. This is basically your BOP part. There will be a testing pressure of maybe 3000 psi or a 5000 psi. You have in your BOP part, you have two spindle. This is your spindle. When you are moving your polish rod, either you are running your SRP or you are testing your pump at your rig, don't tighten these two. You need to lose these two, but not too loose. If you are losing this too much, you are going to see a leakage. Some water will come. If some water comes, you are going to tie it until the water stops. And this is your finger. This is called the finger of the spindle. You should always lose this finger at the most loose position. So that's how you are testing your pump. And one thing you may notice is that when you are nipple down your Christmas tree, you are going to remove your upper master valve and your crown valve and your upper master valve. You are going to make it up to only one master valve, and you will connect your flow arm valve. In any completion of SRP, you are not going to get any upper master valve or your crown valve. So you remove both. Instead, you are going to replace your crown valve with your stuffing box. And you will, in this completion of SRP, especially in your water unloading, for the purpose of water unloading, you are going to produce water from your tubing line, and you will be producing gas from your casing line. And this is your bin housing. Yesterday I was talking about it. And you are going to put some NRV here because you don't want any back pressure through your casing or through your tubing. Now let's move on to the surface unit installation. Basically, this is what your surface unit looks like. This is your SRP, the surface unit. It will come like this. When you order your surface unit from a vendor, it will come like this. This is basically your surface unit packing. And then you are going to assemble in your tool yard or at the field sites. After assembling it, you will transfer it using your trailer. This is your trailer. And you are going to install it using your crane. So you after that, you move your surface unit to the field using your crane. You are going to install it there. And then the next thing you are going to do is you are going to hook up your polish rod that was installed installed during your running in of your pump as well as your sucker rod. So in order to hook up, now one rule of thumb is that you are going to lift your polish rod 3 inches per 100 meter. So if your well depth is of 1000 meter, you are going to lift 9 inches or 30 inches. That is because when you lift your polish rod, your sucker rod, it is going to be expand or an elongation will occur because of the load of your sucker rod as well as the fluid above it. Because of the load, your sucker rod is going to expand. So in order to eliminate that expansion and you want to reduce your compression ratio, which is basically your swept volume plus unswept volume divided by unswept volume. You want to reduce this compression ratio, increase your compression ratio. You want to reduce the gap between your traveling valve as well as your standing valve to be around 1 inches. So the rule of thumb in gas well, if it's in oil well, if it's in oil well, you are going to lift 4 inches per 100 meter. If it's gas well, you are going to lift 3 inches per 100 meter because of the gas gradient is lower than the oil. Basically, your polish rod will be of your 25 or 22 feet. Usually we use 22 feet, but for as the depth is deeper, let's say your 100 meter, 1000 meter to 2000 to 3000 meter, you may want to use your 25 feet polish rod. So when you hook up your polish rod, you are using the polish rod clamp. You clamp it onto the polish rod, and then you will use 1 feet or 2 feet of your pony rod, and you will connect this to the elevator, to the crane. This crane, you will use this crane to lift this, and then you will attach with your carrier bar, and then that's how you are hooking up your sucker rod to your surface unit. After that, you will be able to run the surface unit if there is any power connection. Now let's see, how will you be able to identify the stroke length when you go to field? You saw a sucker rod pumping unit. How will you know your stroke length or the stroke length of your pumping unit? So basically, you will be able to know it. You have your crank. This is your crank. Your crank will have either a 4-hole or a 3-hole. So you see some posts, poster here. From here you will be able to know your unit size. Like this, you are going to be able to find it, and after noticing that your highest stroke length will be of this. The highest stroke length, if it's 320, 256 and 120, the bottom hole is your highest stroke length. If you know the unit, this will be your 120, and if you go upwards, it will decrease to 100, 86 or 74. And if it's 456 unit, this will be your 144, and this will be your 120. This will be your 186. Likewise, you are going to put crank pin. If you want your stroke length to be 120 for 320 unit, you are going to put your crank pin. This is your crank pin. You are going to put crank pin here. If you want 100 inches, you put your crank pin here. Likewise, you are going to shift your crank pin. That's how you are able to know your stroke length for a specific unit. Now, how will you know your exact SPM? SPM is your stroke per minute. Downstroke and upstroke will give 1 stroke. That is the cycle. So how will you count it? When you go to the field, or especially for PDPU student, you have SRP in front of your school building. How will you know the SPM of your the SPM of the sucker rod that was present there? So basically, you can use your stopwatch. You can count for 1 minute, but it will not give you the exact stroke length. So you will count 10 stroke. How long it takes for 10 stroke in second or in minute, you convert it into minute, and you will divide the strokes by the minute, then you get the SPM. Why we use 10 stroke? Mainly because in sucker rod pump, the maximum stroke may be of 10. Why we are not counting only 5 stroke? Because most of the sucker rod pump will have a higher stroke than 5 SPM. Now, how will you calculate your production from your SRP? Well, if you know the plunger size, if you know the SPM as well as the stroke length, you can calculate your production rate, how much you are unloading water from your uh, well. You can calculate it. So basically, you are multiplying all these things after you converting your inches or inches into meter cube, or basically your barrel, because the unit will be of barrel. You may also directly find it in meter cube. So you have your pump constant. Pump constant will be your plunger diameter into the conversion factor of your inches to your barrel, which is of 0.1166. For 1.5 inches, your pump constant will be 0.262 after multiplying the pump size and the conversion factor. That's how you will be able to find out your production using your stroke length, your SPM, and your plunger size. This will be your unloading rate of water or oil per day. So if you run only 2 hours, you will divide it the day. You will convert day using hours divided with 24. Now, what happened in gas well is that the main problem is that you are going to get gas. You don't want your gas to go inside your pump barrel or plunger, because there will be a problem, or there will be a decrease in efficiency when you have interference of gas in your pump. Your system efficiency will decrease. We have a downhole gas separator, mainly natural gas anchor or pour boy gas anchor. What is the natural gas anchor? Let's see. Natural gas anchor is basically your when you are installing your subsurface pump, your pump location should be 20 to 30 meter below your perforation interval. Why? Because when you are producing gas from the perforation interval, gas will tend to move upwards, and liquid, for example water, will move downwards, tends to move downwards because of the density difference. So that's how you will be able to separate your gas from your water. So your water will move, it will have a level. Suppose let's have all of this is your water. So you will be able to pump your only water, avoiding gas using this. Sump is basically a borehole or a hole, a well that is that is available below your perforation, which we call it sump. So you want your pump to be efficient, you want to avoid your gas inside your pump. So that's how you are separating gas from the water. And the next thing is your pour boy gas anchor. In this, you may or may not put your separator below or at the interval of your perforation. This is, let's say this is your perforation interval. In pour boy, you have a completion like this. You have your gas exit and entry of fluid, and there will be two stage separation here. So when gas or water moves from the perforation interval, some gas will directly move upwards to the casing annulus, and the water will retain. So the water will either move downwards to your chamber, your pour boy gas anchor chamber, and from here your fluid will accumulate inside this, and then there is a strain nipple here. Using from your strain nipple, your fluids will move inside to the pump, and then you will be able to unload it using your standing valve and your pump barrel, where your standing valve and traveling valve is there. Like suppose if your separation of gas and water is not that effective here, some gas will also move inside. But you have another quiet space here, because when fluids or gas moves inside this chamber, the gas is lighter, so it will be able to move out of this slot again. So this is your gas exit. Fluid will move inside, liquid will move inside your slot here, and some gas will move outside. That's how you are separating gas and water. There are some operational issues, and in the sucker rod pumping well, there are two methods you will be able to identify, and after identifying it, you can take decision on how to troubleshoot the problem. The first is your echometer, and the second is your dynograph. For echometer, you have your acoustic gun. Basically, it will look like this. You will attach this acoustic gun onto the casing valve, annular valve. You are going to close your tubing flow arm valve and your other valve on the left or right side of your annular valve. So both of them, you should close it, because you don't want any noise coming from the other end. So after you shoot your acoustic, your sound waves, you will record it using your registration unit or your registering unit. For Echometer company, it will look like this. But for the Russian company, we have a Geostar. It looks like a mobile phone type of thing. It looks like a tablet. So this is how you are going to shoot your well. You are shooting with your air gun. So for shooting this into the well, you may require some pressure, maybe 1 or 2 kg. Otherwise, you may not be able to shoot it. So when you shoot your sound, it will travel through the annulus. In each casing collar or the tubing collar, you are going to see a reflection, a kick. You are going to see it. So based on this, you are able to determine or correlate the depth. And then you, finally, when it hits the water level, you will see a very high noise or very high kick. So between, you will calculate zero depth to up to the fluid level. You are going to see a same distance, because you will be able to identify, yes, this is the liquid level, only when these two distance in each kick is same. Basically, you shoot your acoustic, it hits the liquid, and then it comes back and it hits again, comes back, it hits again. So that's why you will have the same distance. So you will be able to identify the fluid level. And for Dynograph, you have your polish rod transducer, you have your Horseshoe load cell. How to install your polish rod transducer? You are going to install your polish rod transducer below your carrier bar, usually 6" to 8" below your carrier bar. And then your polish rod transducer will be, while you are installing your polish rod transducer, don't stop the unit. If your SRP has a higher SPM, you may want to stop the unit for safety purpose. But when you stop the unit and put your polish rod transducer, you should wait for minimum 8 stroke before you record your load using your polish rod transducer. This polish rod transducer will basically record the change in the diameter, the change in the micro change in the diameter of the polish rod, because during upstroke and downstroke, your polish rod as well as your sucker rod will expand as well as contracts. So that change in the diameter will be converted into load. So that's how you are recording your load with your stroke length using your PRT. So the polish rod transducer location and position of how you put it below 6 or 8 inch or above, it will be very important, because if you are not putting your polish rod transducer properly onto your polish rod, you may get this type of load versus stroke length plot on your dyna card, because sometimes your polish rod, if you are not uh, greasing it properly, it may corrode. So the change in diameter will affect your polish rod transducer. And also when you tied your polish rod transducer to the polish rod, you will be given a light signal. Too much tight may blink fast, and you are going to tight it based on the indicator. There will be a light there. And the second thing is your horseshoe load cell. You are going to install between your carrier bar and your polish rod clamp. So when you are going to install it, you can do one thing. If you want more safety, you can use crane to lift your polish rod. Then after lifting, you put your horseshoe cell or your load cell, and then you lower it down, and then you start the unit. And the second thing is that without crane also you can do it, but you will need 2 polish rod clamp. You will clamp one here, so when it goes downward, downstroke, your polish rod will be hanging by your clamp. So when it hangs, this carrier bar will move downwards. There will be a space between your other polish rod clamp and your carrier bar. So inside that, you are going to put your load cell. And the load cell will measure directly the load. It is very accurate compared to the PRT, but the PRT is very simple and easy. When you visit well, you can easily take it. But for polish rod or the load cell, horseshoe load cell, you may need crane, or you may want to stop the unit. So this will not, the position of the polish rod or the diameter of the polish rod will not affect your load measurement using your load cell. Let's see the dynamometer dynamometer test. Using your PRT and your load cell, you are going to measure your load versus your stroke length. So you will be able to analyze it once you are plotting the load versus position. So you are going to have a two plot. You will have your surface card and your subsurface card, and this is your load. The load means your the sucker rod, as well as your fluid and your polish rod, and this is your stroke length. Now when you are measuring it, let's see here, you can divide this into 4, A, B, and C, D. A to B is your upstroke, and when you are moving from B, C, basically your this will be transferring your upstroke to your downstroke. During downstroke, your traveling valve will open. Because of the traveling valve open, your load is lower, and when the sending valve is traveling during upstroke, you are lifting all your liquid that goes inside your plunger during downstroke. So your load will be more compared to your downstroke. And this will be your anchored tubing. Basically, this is your subsurface card. You have a straight line, or rectangle shape. That means that your tubing is anchored, which will tubing anchored catcher. You are installing your tubing anchored catcher, which will eliminate your stretch of the tubing. So you are going to get a rectangle. This is the ideal condition, but in practical, you may not get the rectangle, but it will be more or less similar to it. But when you your tubing is not anchored, you are going to see a rhombus shaped type of dynacard, because you are going to see a space, a gap between this A and the distance, because this part will be because of your tubing stretch. During downstroke, your tubing is going to be expand, because all the fluid loss as well as the sucker rod will act against the tubing, so your tubing is going to expand. And during upstroke, this is your contraction. Your tubing is going back to its original position during upstroke, because all the fluid load will act onto the sucker rod or the plunger, not on the tubing. Only during downstroke, the tubing will act, the load will act on the tubing. During upstroke, it will act on the pump. Now, for analyzing surface and pump card, the subsurface pump card is for designing and diagnosing the surface problems, your rod string, your pumping unit, is there any friction, if you have excessive friction or not. So in the surface card, this is your unanchored tubing. As you can see, because of the tubing stretch, that means that your tubing is not anchored. If you see at the surface card, you have your rod stretch. Like I said, during upstroke, your sucker rod is going to stretch, expand. This is indicated in your surface card. This is your rod stretch. This will be your original pump stroke. And because of the stretching, your effective pump stroke will be from this to this only. So there is a reduction in your stroke. That means you are going to leave less liquid. And in the downhole, like I said, you have your tubing stretch and your net pump stroke, and the distance between the, this is your polish rod PPRL. It will be your peak polish rod load. This will be your MPRL, minimum polish rod load. Between this, you have your fluid load. This is the fluid load, which is the fluid that will act against your pump, your plunger. So it will be, it will depends on the density of the fluid as well as the height. So more or less, it will be of raw GH. For pump card, you can decide whether it's unanchored tubing or not. So like I said, this will be unanchored tubing because there is a tubing stretch, and you will be able to identify your tubing leak, pump problems, and pump displacement, whether your pump is displacing more liquid or not. Now let's understand the basic concept here. You have peak polish rod load, the PPRL, which is your weight of rod in fluid plus the fluid load. This is going to be your maximum load on your polish rod, and you have a minimum polish rod load, which is your weight of rod in fluid minus your fluid load, because during polish rod load will mainly during upstroke, and minimum polish rod load is the load during downstroke. So sometimes you are going to see your minimum polish rod load below your normal weight of the rod. So this may be sometimes also comes negative also. And counterbalance weight, balance effect is important while installing the surface unit. How much counterweight and at what position you are going to put your counterweight, which is your peak polish rod load plus your minimum polish rod load, and that will be your average, basically your average. So for counterbalancing, it will be your CBE, your counterbalance effect will be somewhere in between your peak polish rod load or your minimum polish rod load. And like I said before, this distance is your fluid load. You have this type of curve because of your movement of your rod. So because of the movement, sometimes your load is high, sometimes your load is low, because that will be recorded using your PRT or your load cell. That's why you are not going to get any straight line, because your load will not be constant. Now let's see what are the expression that is given to your pump card. For maximum plunger travel, we call it the MPT. That will be your original stroke length that you are going to set at the surface. You are assuming your stroke length to be same as your pump stroke downhole, but it is not going to be same because of the expansion and the contraction. This is your maximum plunger travel, and the distance from the right to the left in your dyna card will be your effective plunger travel. And like I said, the vertical distance will be your fluid load. For tubing anchor, your pump card will be more or less rectangle. For your unanchored tubing, it is going to be like a shape of rhombus. Now let's see what are the subsurface failures that can be classified into operational, well-conditioned, and mechanical. For operational, it may be your bottom hole assembly design is not proper, so you may have to deal with the inefficiency, and there is a bad spacing of pump. So like I was explained before, during your hookup, you are going to adjust your polish rod 3 inch per 100 meter. So during that, you are going to try to lower this space, maybe maximum 1 inches, but not hitting your standing valve using your traveling valve. So you are trying to increase your compression ratio. Bad sitting nipple, and you have a problem in deviated wells, and for tubing anchored or unanchored tubing. Well-conditioned failure, you have your fluid pound, gas locking, sand, because of sand and because of scale and because of corrosion, you are going to have a well-conditioned failures that will be related to your efficiency of your pump. So now let's look at the gas locking or the interference. The gas interference is basically your traveling valve is opening late because of your compressibility of gas. When the gas is flowing into the chamber because of gas compressibility, your traveling valve will open late. So you are going to lift less liquid. Only when you reach your fluid level using your traveling valve, that much liquid only you are going to lift. And for gas locking, you have much lower fluid level inside your barrel. So in that case, because of the gas compressibility and heavy, larger pressure inside your plunger, your traveling valve will not be able to open during downstroke. In that case, you are not going to see any unloading at the surface. So basically, you are not loading zero, you are giving zero production of the liquid, which will be affect your efficiency. How are you going to solve this problem? So basically, you are going to pump some fluid, some liquid from the annulus to your tubing. So you are doing reverse circulation, and you are trying to reverse, you are trying to replace all this gas using your fluid. So you will do reverse circulation in case of gas interference or gas locking. But that is not always the case. Sometimes you will close your sucker rod pump so that your fluid will accumulate more inside your pump. So this is one example. This is one of the well in Rokia field, RO31. Like I said, during downstroke, you are going to see your traveling valve opening at very late. Here, your downstroke starts from here, but your traveling valve opens here because all this is because of the presence of gas. So only when you have compressed your gas to be able to open your traveling valve, you will only see an opening in the traveling valve. Only this much you are going to be able to lift liquid. So the fluid load is also less, especially in gas interference. So we have a solution. We calculated the influx rate. So we decided to run only 2 hours per day of sucker rod. So we run only 2 hours in this sucker rod pumping well. And then we have a fluid pound. Fluid pound is almost similar to your gas interference, but in the case of fluid pound, you have a fluid level, a very low level in the chamber, inside your plunger as well as outside in the annulus. Because of that, there may be no gas there. This will be a void. So when during downstroke your plunger moves downward, you are going to hit the liquid level very hard. So there will be a sudden opening of your traveling valve, as well as there will be a shock traveling to the plunger and to the rod, and then it will travel to the surface. So it will affect your surface unit movement also. We can see here is an example of the fluid pound. It's almost similar to your gas interference. The thing is that you have a sharp drop in your load. This is one of the well in Rokia also, RO18. This SRP is installed in 2017, which was the first SRP installed in ONGC for water loading, for unloading the water. So in this case, you have a sudden pressure drop here. From this section, pressure drop means that your traveling valve is suddenly open during downstroke, and then only when the traveling valve is open, you are going to see your fluids going into the plunger. Only this much you are going to lift liquid. Similar to the problem in gas interference, at this time we are running only 4 hours per day the sucker SRP, so that we have more influx inside our well bore. One more problem is your deviated well. In deviated well, the problem will be your side friction because of deviation. Usually in deviated well, you have your dog leg severity, which is the severity of the change in the borehole inclination. Usually this will be limited by 3 degrees per 100 feet. So you don't want your well to be dog leg severity to be more than 3 degrees per 100 feet. Basically, we can be calculated using your data. I will show you one sheet. Can you see my desktop? Hello?
Yes, sir.
Okay. Okay, this is how you are going to calculate your dog leg severity. You have your deviation calculation. Basically, you are going to get your measure depth, your angle, and your azimuth. From this, you will be able to plot your inclination of the well. If you plot your measure depth versus the drift, you are going to get the shape of your well. Now let's reverse the value, and then we will get the well profile. So this is your well profile. This is around 500 585, you have your kickoff point. So this is your well profile. And you are going to compare your well profile with your dogleg severity. And also you can plot your dogleg severity using your measure depth versus your DLS. This is your dogleg severity. Like I said, you don't want your well to have a dogleg severity more than 3 degrees per 100 feet. Now, if you see here, somewhere you have 3.3 degree per 100 feet, you have 3.6. In this case, you are going to use guide shoe or sub-molded guide for your centering your sucker rod, like your centralizer. You are going to use centralizer during drilling. When you drill your deviation well, you may use your centralizer, etc., like that. Similar to that, you are going to use a guide rod or a wheel guide to centralize your sucker rod in deviated well. That's how you are solving your deviation problem. Now let's see what are the guidelines for monitoring the sucker rod pump. In order to check your pump is working properly or not, you are going to do a build-up pressure. In this case, you are going to close your flow arm valve. You put one pressure gauge at your tubing head, which will be your tubing head pressure. You are going to, for example, you will be checking an increase in pressure after closing your flow arm valve, usually 5 kg to 40 kg. How fast you're building the pressure from 5 kg to 4 kg, which may be in 3 minutes or 5 minutes. Depending on that, you will be able to judge whether your pump is working or not. If you are if your build-up pressure is very slow, that means that some gas may be present inside your pump. So you may want to eliminate that by closing the SRP, shutting down the SRP, or for reverse circulation. When you check your BOP, if you're after reaching 40 kg, you will wait for it. You will close your SRP, and then when you close your SRP, if there is any decrease in your pressure, if the pressure is not hold, you will check your casing pressure, and if your casing pressure is very high, you are going to release the casing pressure, and you are going to do your build-up pressure test again. If you observe flow of liquids, in your tubing, but when you are doing build-up pressure, and if the build-up is not holding, you need to check whether your well is activated. Activated means whether your well is flowing without unloading liquid or not. And then you are going to check your polish rod temperature also. If it's too much hot, that means that the liquid is very low, or gas is much more. So at that time, you may shut down your SRP also. And when you are checking your upstroke and downstroke, during upstroke and downstroke, you are going to check in your control panel the current withdraw by the upstroke during upstroke and downstroke. Usually, it should during upstroke and upstroke, your current should not be the difference should not be more than 15 ampere. So if it's more than 15 ampere, you may want to relocate your counterweight. And also check whether is there any abnormal sound or vibration on the surface unit. And you can optimize your unit using your structural loading. You can calculate using your unit size. Your structural rating is your 256, and your peak polish rod load, you can calculate it from the Dynacard. If it's more than 60 to 70, you may want to increase your unit size. This is how your structural loading. If it's too low, that means that your unit is too big, so you want to reduce your unit size. 40 to 70 is your optimum unit structural load. If it's more than 70, you are going to increase the unit size. The other thing is your gearbox loading. This will be calculated using your gearbox rating in your unit. This is a 320, and your peak upstroke torque, which you will be getting from your dyno card also. And then you can know that if it's less than 80%, that means your torque is fine, your gearbox is fine, that is good. 80 to 95%, you need to consider a new unit. 95 to 115%, it will probably withstand your load, but you may want to increase your gearbox rating. That means you need to increase your surface unit, and greater than 115%, your gearbox will fail. For pump efficiency, if your pump efficiency is 0 to 60, you will reduce the pump capacity. That means that you will use a lower SPM or a lower plunger size. Pump size, 60 to 90% is the ideal range for pump efficiency. If it's more than 90%, you will decrease your increase your SPM, or you will increase your pump diameter. And for sucker rod pumping design, we will need this minimum information: the fluid level, the pump depth, the pumping speed, your plunger diameter, your stroke length, and your specific gravity of the fluid, tubing diameter, whether your tubing is anchored or unanchored, and the sucker rod size and the combination. So basically, from your pump displacement formula, you can know if you know how much you are going to unload, you will be able to decide the SPM, your stroke length, and your pump diameter. So that is it for today. And now we will quickly look for software that I was asking you to download. But the problem here is that I am not able to get a proper display in the software, maybe because of the compatibility problem. This software will usually run better in Windows 8 than a Windows 10. This is the older version, so I will be checking this with both the version 2.4 and 3.1. So you will be seeing the first design input will be either you have your clockwise conventional or counterclockwise conventional, and Mark II or air balance. So based on that, depending on your surface unit, you will be selecting whether it's clockwise or counterclockwise, and then you can input your depth and stroke length. You will decide which stroke length should I use based on how much liquid I need to unload. How much you need to unload, you can decide from your influx test. If the influx is more, you will want to unload at a faster rate. And your tubing size, 2875 is your 27 by 8, which has an internal diameter of 2.441 or a 6.4 pounds per feet. And here the anchor tubing means whether you are using an anchor tubing anchor catcher or not. Usually you are not going to use it. And the next is your rod number. What is the combination of your rod? If it's a 76, that means 7 by 8 and 6 by 8. If it's 77, that means 7 by 8, only 7 by 8. And grade, your rod grade. And in the default setting, if you look in the default setting, you can calculate your sinker bar. Sinker bar can be calculated from your pump diameter, pump depth, your specific gravity. Usually your sinker bar may be of your 7 by 8. It will be of 0.875, you can calculate it, and then you get this recommended length of the sinker bar. And if you divide this by 25, you will get the number of sinker bar you need to use. Now you use it, and you have a fluid specific gravity. Basically, you are unloading water, so your specific gravity will be 1, and you after that you use the calculation. And tubing pressure, depending on the surface tubing pressure, you are going to put the tubing pressure and the casing pressure. And pump intake pressure, this is your pump intake pressure is your hydrostatic gradient plus your casing pressure, which will be greater than your casing pressure. So if you add your casing pressure for to be, let's say, 100 psi, for example, because of your liquid plus your casing pressure. Now let's move on to the next. You have the damping factor. Damping factor is the magnitude of the friction loss because of between the surface from the pump. This will be a value between 0.1 to 0.5, and then you have a unit efficiency. And for pump volumetric efficiency, you have these inputs: the pump diameter, pump depth, tubing intake pressure, and all this. This clearance is your clearance between your plunger and your barrel. It can be 0.004 or 0.006, etc. And your fluid viscosity, this is your plunger length in inches. 48 is your 4 feet. If it's 6 feet plunger, you are going to input 72. And then it will calculate the slippage. Slippage is going to be dependent upon the SPM, your pump pressure differential, and the clearance. So the more, if you have higher clearance, you are going to use higher SPM as well as a smaller stroke length, etc. So that's how you are calculating your clearance, and then this will decide your pump efficiency, and then you calculate it. Now let's see, once you input all these things, you are going to decide your SPM. Based on your SPM, you calculate it, you are going to get a plot of this. This will be your Dynacard. This is the ideal one. And you have the pump velocity versus position. If you, when you design your pump, you want your pump velocity versus position diagram to be more and more circular. And for your Dynacard, the better the Dynacard or the pump, when you have the Dynacard more and more looking like a rectangle or a rhombus. And you have the torque and the angle during upstroke and downstroke. And here are the results. When you have a pumping efficiency with 320, 173, and 100, you are unloading 88 barrels per day. And if the rate is 95, you are unloading 84%. This is your tapered rod tapered combination, 100%, because you are using 77. Now, if you are using 76, it is going to be 33.8 or 66.2. That is how you are designing your pumping unit. Minimum pumping unit rating, this is 228, 133, and 100. This is the minimum. You should not use pumping unit lower than this. So that is the quick view for your sucker rod designing software. That is all for today. I hope you enjoy it, and I hope you gain at least something from this session. Thank you, and if you have any doubt, you can ask.
Yes. Thank you, sir. I am Yogendra from 4th year. I have one doubt regarding the subsurface pump classification, in which the first digit that we are having 25,
Yes.
which is nominal diameter of rod tubing.
It is the
Sorry,
outer diameter.
outer diameter of tubing.
Yes, tubing. 25 will be your 27/8 tubing.
27 by, okay. Okay.
20 will be your 23/8. But your 27/8 tubing, depending on your PPF, you will have different diameter, but this is the nominal diameter.
Okay. Thank you, sir.
Okay. Any other question?
Do we have any further questions? Anyone?
Sir, can you please elaborate more on pony rod, polished rod adjustment in the hookup, which you were talking about 3 inch
Okay.
per 100 meter.
Okay. So when you are, excuse me, 1 minute. When you are adjusting your polish rod, basically the problem is that because of load, your polish rod as well as your sucker rod is going to elongate it, right? You understand that part?
Yes,
That
sir.
you are going to see an elongation in your sucker rod.
Yes.
And when you are hooking up your polish rod using your crane or your polish rod clamp, that means you are going to leave some distance in your polish rod, right? So this polish rod adjustment will limit how much length should I lift from the above the stuffing box. So suppose if your well depth is 1000 meter, you need to lift 30 inches
30 inches.
above 30 inches. This should be 30 inches. So the distance between your stuffing box and your carrier bar should be 30 inches.
Carrier bar should be, yes.
Yes. So that will depend on the depth. In oil well, you are going to lift 40 inches per 100 meter, but in gas well, you will lift only 3 inches per 100 meter. That is the rule of thumb.
Okay. Oh, thank you, sir.
Anyone else? Okay then. Thank you everyone for your patience. I would like to express my sincere gratitude to Mr. Alphonse Lalnuntluanga for sharing your knowledge with us despite your busy schedule. We hope you liked the experience and hope for you to join us in other such events as well. The link for the online quiz will be sent to you on your respective email IDs. This link will expire at 7 p.m. so make sure you submit before that. Everyone can now leave the meeting. Best wishes to you all.
Okay, thank you.
Thank you, sir.
Thank you, FIPI, and thank you, Ms. Komal. It was a pleasure coordinating with you. I hope you enjoyed the session.
Yes, sir, sure.
Hello. Hello.
Yes?
Yes.
Hello, sir. This is Shivkumar.
Yes, yes.
Sir, I have a question. I have a question for you personally, sir. Can you share your experience in ONGC, and what is your qualification as to be in a ONGC?
Actually, I joined in 2018. During my interview, I want to be a reservoir engineer. But because of some people who were selected earlier than me, I'm not able to select my preference, which was reservoir engineering. And one of the person who interviewed me, he said that if you want production, we will select you. So I said, I want a job, so I chose production. And till now, I have great experience, especially in Tripura, I said, because this liquid loading problem is coming up, and we started this section, the specialist pool artificial lift, in 2018 after I joined ONGC. So the main problem we are dealing with is to deliquify this thing, and I had a great experience working with the reservoir people as well as the well service people. Overall, it is good.
Sir, thank you, sir. Sir, what are the chances to be petroleum engineer in
I'm
ONGC?
sorry. In ONGC, right now, the recruitment is halt because of the coronavirus. Maybe, I don't know exactly. But I think everywhere the petroleum recruitment percentage is reduced, if I'm not wrong.
Okay, sir. Thank you.
Okay, no problem.
If anyone has any questions, they can ask. Okay, then, so the meeting is officially over. Like, we can all leave the meeting now.
Okay,
Thank you.
thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.